All right. Hey, everybody. Welcome to Cluster API Provider Azure. We are a SIG lifecycle project, and we follow the CNCF guidelines. So if everybody's here, let's try to be nice to each other and be friendly. Use the raise hand button if you'd like to be noticed. All right, awesome. So let's see, our reoccurring topics today. Do you have any new members or anybody in here that would like to say hello? Introduce yourself.
Maybe I can tell two words. So my name is Piotr Szwed. I just started to work with Cluster API in two projects, actually, for two companies, my old previous employer and the new one. The previous one is a heavy Microsoft user. So the Cluster API Azure provider is very important for them. And the new one is a startup where we are going to support multiple different clouds. So that's also a very use case for the project. So I think I will spend at least a couple of weeks with your project, including other providers. I'm going to do a lot of testing. I'm going to set up POC and a number of topics related to that. So yeah. What is the most important thing to me is the maturity of the project, because we will need to decide if we want to go with Terraform or Cluster API and its providers, right? So for both the projects, for the Grand Force company and the new one, Starburst, it is quite important to know if it is ready to be used in production for serious production deployments or not. So that's also one of the reasons.
Indeed, welcome. Thank you, Pierre. We're always interested in hearing any kind of issues that you come across, and happy to help prioritize those. So welcome, thank you. Anybody else?
Peter, I'm definitely interested in your sort of multi-cloud use cases when you have time to talk about it.
Yeah, maybe we can get into a little bit of discussion later. All right, if nobody else wants to speak up, then we move on. 1, 2, okay. All right, everybody. So let's see, if you haven't, please add your name to the attendees list. And do we want to get into project board?
Let's circle back at the end.
Sounds
good.
Is that
okay?
Yeah, super. Open discussion. All right, so let's see. Cecile, I think you're first on the list. Plans for release. Thanks.
I actually sneaked that in right at the end before Nader. Sorry, Nader. But I just wanted to quickly, it's kind of a PSA, but so the release, so we're nearing the end of the month, which we had targeted for the next release. And so I just wanted to see, I know that Cluster API is not going to release 03.11 until probably the end of next week or the week after. So I was thinking we should probably, if everyone's okay with that, delay our release by a week to just follow the Cluster API release, so we can take in Cluster API and test with that before we cut the final release. And also gives us another week to finish some of the big items that are in the milestone that I know are in progress, like the start of multi-tenancy, the private cluster PR, which is under review. And then there's another one, I forget, but oh, the GPU node one is also pretty much close to being ready. So I don't know if anyone has any objections, let me know. I don't think there are any critical bugs or anything that's in the main branch right now that is like pressing. It's mostly new features, but if you know of something otherwise, please say so.
I would say investigation in machine pools would be something that we'd probably want to get in, perhaps. So just in case anybody is not aware, we've run into a issue with machine pools when adding nodes or scaling up nodes. after a long period of time due to the join token expiring. So you need to keep that join token lively so that new nodes can join in when using a VMSS or VMSS related stuff like agent pools, stuff like that.
Yeah.
Is that only a problem for VMSS?
Yeah, it should be, because the way that we modeled machine pools is that each instance underneath the machine pool, unlike Azure machines, is using the token that was allocated for the Azure machine pool. So as each new instance is built, it's using that same bootstrap token. So that is, it just only gets created and then has a TTL of 15 minutes or so.
Cool, thanks for the clarification.
That's another reason to delay the release though, right? To try to get that in.
That would be great if we can. Likelihood is that we'd actually have to get a patch into CAPZ, and then really delaying the release isn't. Maybe if we can find a mitigation, because the real fix is going to be in CAPZ for this, I would imagine.
But I mean, we would have to delay the release to pick up their release anyway, so I think it makes sense for us to wait for 3.11.
Sure. Yeah. Anyone else have any things that would be valuable to get in before? Let's see, chat. Awesome. Thanks, Matt.
I don't know, is everybody else's audio kind of warbly or is it just me?
I think it's just,
Okay, I won't worry about it.
but we can hear you pretty well.
Okay. Yeah, totally.
All right, carry on.
Cecile, did you want to add anything else to that?
Nope, that answers my question. So I think I'll just hold until after CAPZ to cut the release and start the new milestone. We can probably plan the new milestone in the next office hours, so in 2 weeks, if that's okay. Great.
Super. Nader, you have the floor.
Yeah, so that's my my weekly discussion topic about flaky test. It's about the KCP upgrade one. Fabricio opened a PR in Cluster API about that the KCP is reporting the wrong number of machines when it's rolling like the update, which I don't know if is the thing causing our test to be flaky or not. But he has a PR open for it anyway, so once it's done, I will pull that in and test with it. But through all my testing locally and stuff, it just like the machine, it does everything in serial. So it creates a machine, and creates like all three of them, and then creates one of the new version, and then start deleting an old one, and then creates another one, and then deletes one, and so on. So it just takes a long time, and then we eventually time out in our test. In my local environment, I've never been able to get it to time out, and I don't know why that is, but just like an update, I don't know. Don't have any like solid answers yet, but if anybody has thoughts, I know Cecile looked at it. Did you notice something that we can investigate further, or?
Yeah, so I looked at the logs of some of the failures that happened recently, and now we have more logs, so it's easier to look at the CI, CI failures. But yeah, so what I noticed is basically what happened is there's a fourth control plane that's left at the end that is one of the old Kubernetes version. So basically all three of the new control planes come up correctly and they're running the new version that we upgraded to. But the first two get deleted properly, but the third one, its old replica doesn't get deleted. So we end up with like old nodes remain at the end. It times out waiting for that node to be gone. What I noticed is it did not attempt to delete the machine. So the machine is not in deleted state or deleting. It doesn't have a deletion timestamp. And so that the Azure machine also isn't being deleted. So it's not like a timeout in the environment trying to delete Azure resources. It's really timing out, waiting for KCP to say, okay, delete that machine. And so I think that's an issue not Azure specific. I think it's at the CAPZ level where it's trying to do the rolling update and somehow it's not finding that it should delete the third replica, the old one. So to me, it looks very related to the issue that Fabrizio opened, that you pasted.
One thing I've noticed, because I kept looking at this, is that there's like a lag of a few minutes between each step. So it would create the three of the old version, and then wait a few minutes, and then create the first one, and then wait a few minutes, and then start deleting, and so on. So I don't know if that has to do with like the reconciliation loop or something, but something in KCP waits between each step for some time before anything happens. So anyway, I will test with Fabrizio's PR once it's in and see if it has made things go faster for us.
I wonder if it's collecting the node references and it waits for those node references to eventually like fall off the list. Like they haven't reported into API server for a little bit, and then API server says, yeah, they're not there.
Maybe. Not sure.
Definitely a fun one to dig into though.
Yeah, I'll look at that. And Fabrizio's PR is already in progress, so hopefully we'll get it and test with it.
Awesome. Let's see. You have the next couple.
Yep. Next one. So in VMware, we started using CAPZ and supporting Azure, and we're doing some scaling testing. And I got a question saying from the team doing the scale testing, saying that once they were trying to create a cluster with 500 nodes, and they got a hard limit of availability, like VMs cannot more than, like the resource group cannot have more than, or you cannot have more than 250 VMs in the availability set. And they said that this is like a hard limit on Azure. And I had some discussions with like a bunch of people, including Nadir, who I think is here for that reason. And then was wondering if you guys have thoughts about that. I think machine pools would be like something we can look into that wouldn't have that limit, but is that limit, are we doing something wrong that's causing that limit because it shouldn't be there, or is that expected, or what's your thoughts?
So one question, we're not deploying any availability sets in CAPZ. Is that something that you're doing on top or modifying?
No, I think what they said is availability sets are getting created by default. And I was just looking, and I think it's because there's no zone, like there's no availability zone. So availability sets gets created by Azure when you create a VM in a non-availability zone or something. I don't know where the availability sets came from because there's nothing in the code that says create an availability set.
Yeah, that's an interesting behavior because I have not seen that. And that's actually one of the things I wanted to bring up later, because we're running into issues with PVCs because we're not deploying availability sets. So I would love to see like we should look into this. But regarding your question, yes, you should use VMSS. That's one of the reasons that was one of the main things in the machine pool proposal that we brought up as one of the motivation is large clusters, because exactly of that limit. And so with VMSS, you can have up to 1,000 instances. I think that was the case last year. Maybe it's better now, but 1,000 instances per scale set. And then you can have like 800 resources per resource group. So you can have multiple scale sets.
When I created my cluster to test this, I don't see any availability sets created. But at the same time, I have my VMs in availability zones, And I think that cluster didn't have an availability zone. So would Azure create a set just because you didn't specify any availability zone, or in a region that doesn't have that?
I don't think that's default behavior. I don't think Azure would create the set for you if the zone is not there. Like if David met, does anyone know otherwise?
I don't think it should create the set unless you tell it to. That strikes me as a little bit odd. I'm not saying that it isn't actually happening. I would love to I'd love to reproduce this.
No, I can get more information about exactly what happened. But I know there's an availability set and it's giving that error. I have the log message saying you cannot have more than 215 in the availability set. So
Right.
I can get like the YAMLs and stuff.
Yeah, I don't doubt that resource limit exists. I'm just skeptical that CAPZ is creating availability sets. So I'm not sure how those sets are getting created.
Okay. Okay. Nadir, is there anything else from our discussion this morning that you want to chat?
I think it's probably more related to Cecile's last item. CAPZ and Kappa are both thinking of creating CRDs for these types of resources or placement resources, and then linking them into clusters and machines. It's not fully figured out. I think CAPZ is further along the design path. So yeah, that is probably relates to that, exactly that last issue.
Hey Nader, is it okay with you if we jump to that one and then come back to multi-tenancy since it's sort of related?
Sure.
Okay, so what I was going to bring up is that yesterday, we did a bunch of investigation on Slack with a user who brought up an issue they were running into with PVCs. We did fix the initial issue. It was a bug in an older Kubernetes version, so using a newer Kubernetes version fixed that. But there is another issue that I was able to repro, which is when using a CAPZ cluster with VMs, so not VMSS, if you install the in-tree storage classes and then you deploy a PVC, then there's a thing in the cloud provider that expects either VMs to be in availability sets or VMSS to be a scale set. And there is no knowledge, I think, in the cloud provider of VMs using zones. So I think that's historical because AKS only supports VMSS with zones. It doesn't support VMs with zones because VMs were like the VMSS is the newer default. And so I think that's a problem in cloud provider. The only two things that we can do to address that from our side that I know of is either one, tell cloud provider config to use the standard VM type. So you know how in cloud provider config you can choose your VM type. It's either standard or VMSS. But if we set it to standard, then that won't work for VMSS nodes, which means we're blocking ourselves from having mixed node clusters. That's not good. Or the other thing is to put everything in availability sets, but for VMs. But the problem with that is we don't want to do that systematically. We want to use zones where we can. So that's where I'm at. I opened an issue and discussing it with one of the experts there, but I think this might require some changes to the cloud provider because CAPZ is breaking some assumptions that were made around the other Azure Kubernetes implementations.
Anybody have any questions on that?
If you put things in availability sets, that wouldn't work for machine pools, right? Like
no, so machine pool is VMSS. That's different. That's working.
So it doesn't have that problem.
It doesn't have that problem.
It doesn't have the problem? Oh, okay.
No, so the problem we're seeing is with a VM, not VMSS, with a machine, it says not a VMSS instance. It's failing because it's trying to see if it's a VMSS instance. Because basically, if you look at the code path, it's linked in the issue. It just says, is this an availability set? If not, then assume it's VMSS.
Yeah, that's just, I think that's something we really need to fix upstream into cloud provider, right?
Yeah.
Like it really needs to have basic knowledge about VMs being in zones.
I agree.
Okay.
So what is the short-term mitigation?
So I guess the short-term mitigations would be either we add availability sets in Azure, but I think that's more work and it's not necessarily something we want to do. Or for now, we say you can't have mixed node clusters and we set the cloud provider config to standard when using VMs and VMSS when using VMSS. If you want to use PVCs, because I think that's, we also need, I'm sure there are other use cases because this code is being reused in other places in cloud provider, but that's the only one that I found not working so far.
So is it just not applying the topology labels properly?
So it is. It's when it's so the volume gets mounted proper, or it gets created properly, but it's the attach that's failing. So during the attach, there's this get node VM set function where it tries to get it and then it does the attach. And when the get fails because it's not looking for the right VM type.
I see.
Yeah. And this is not any like new code or regression or anything like that. It's been there for a few years. So
yeah. All right. Any other questions on this topic? All right. Thank you for the deep dive. That's cool. I wish it was not an issue, but it's great to learn more about that. I guess back to Nader. You want to talk about some multi-tenancy and the fun of using AAD pod identity?
Yeah, so I think I'm getting stuck on this thing where I keep getting identity not found. And Anish said that it might be a bug in IMDS that he's looking into, because sometimes it doesn't return the identity with that error. Because I'm doing all the other things, I confirmed everything else that he said I should have, and I have it. So I don't know how to get around that.
Okay, so some quick questions. What kind of identity is it?
User assigned identity.
Okay. Did Anish talk about the nature of this issue for IMDS?
It's on the Slack thread that you were on, like this long one. He just said there's an IMDS bug that's we're chasing internally, which caches the wrong creds and returns identity not found.
Yes. I believe if you ask for the identity before it has been bound to the machine, before it has actually been attached to the Azure VM, IMDS will cache the result, and then the result will stay in the cache for a period of time, and you will continue to see identity not found. So basically, it's just caching that 404. Like it didn't see that ID, and it caches it. I believe that's the situation.
So I have to make sure it's attached to the machine first before I try to get the token.
I think that is one, like that is the short-term mitigation. Longer term, it should not cache that. It should, ask again to see if it has the identity available to it again. Though I wonder if there's something else going on as well, and it might be just that this one's difficult to diagnose. Would you be interested in pairing up? I'd love to take a look at it.
Yeah, I'm totally getting stuck.
Yeah, let's hack on it.
Okay.
Anybody have any questions about this one? All right. Yeah, shout out to Nadir. Thank you for the lovely starting point for the multi-tenancy documents. You're awesome. All right. Let's see. Anything? So do you want to, Nadir, do you want to talk about the CAPZ failure domain proposal?
Only if you're interested. So if you are thinking along the lines of creating those types of resources, then probably makes sense to align it a bit, I guess, in the same way that we've done for multi-tenancy. So yeah, we're basically, particularly for on-premise, its failure domain is kind of like however the data center has been set up. So you kind of have to give some of that information. So we're going to enable the ability to drive that setup in vCenter via Cluster API, and then AWS Cluster enables machine can consume them. We're doing for AWS as well, because we only support availability zones, but now there's all kinds of zones and placement groups that they've added support for, so which make things really complicated. So we have to go along the same kind of route.
Yeah, right now we're just modeling them on the resources themselves, like it's an integer for the zone, or a set of string, like basically a set of integers. Yeah, it would. I don't know how others feel about it, but it's complicated and it's not just transparent to the naive observer, you know. Any other thought? Anybody have any thoughts out there?
So how does this relate to what's currently being done for like the KCP failure domain spreading?
Not really figured that out yet. I don't know if we need to do some changes for CAPZ v1 alpha 4. I'm kind of like seeing what the end users are sort of deciding on what they want the behavior to be, and then I think we do need to figure out what should look like in CAPZ. If we do need to make changes how failure domains work in CAPZ, I don't know the answer right now.
Sounds good. Thanks for sharing. I'll look through the proposal.
Okay. All right. Anybody have anything else they would like to cover during discussion, guys?
Did we want to dive in a bit in the use case of the multi-cloud? I think it was managed clusters.
Yeah, if he's interested. Piotr, would you like to tell us a little bit about your use case and?
Sure. Sorry, I lost you for a second. So basically, I'm representing potential users, right? And I know the project since its beginnings actually, but I am not yet sure if this is, if it is ready to be used for real production use cases. And I'm also not sure how open you are to contribute to your project, because if you decide to go with cluster API, seeing the how early stage of the project we have today, I think that we'll need to assign at least 1 or 2 developers to the project from our side, right? So all the urgent and custom needs and bugs we find are quickly solved on our side. So these are the major topics I'm interested in. Of course, we'll be also looking into the other providers, Amazon and Google probably in the meantime. But yeah, Azure is one of the major ones for us. So we need to look deeper into the cluster API itself and the Azure provider. So, this is actually first time I'm joining the call, so maybe you can tell me about your feelings. I guess there is also some history here in this documents. I will review all of them. I see that there is Giant Swarm involved in the project, VMware, which is something completely new to me. So it would be nice if you could maybe elaborate a little bit more. How do you feel today with the maturity of the project, and if it is ready to use or not? I'm really extremely surprised by the quick support I got on Slack from you guys. So that was really amazing. But yeah, for us, it's like a big bet today, right? We will have to hire at least 2 Golang developers to make the platform enough stable to deploy production workloads with use of cluster API and Azure providers. So yeah, anything related to that, I will be happy to hear from you.
Anybody? All right. So I'll kick it off.
Our use case is pretty simple. We want to provision a cluster API cluster that will be responsible for managing hundreds of Kubernetes deployments, EKS, GKE, and IKS. So we want to have a kind of management cluster. In Zalando, they call it lifecycle manager, cluster lifecycle manager, I believe. This is their own, custom implementation, which looks much different than cluster API. So we don't want to use it. So this is our use case, and my job for now, for the next few weeks, is to assess, if cluster API will be able to do the same job as like we do with Terraform today.
So you're mostly interested in the managed cluster side of the story, not the unmanaged clusters, just to.
Yes, I spent the last 5 years in consulting, and actually what I see today is that no one is interested in managing their own clusters anymore, right? Everyone, at least this is my own experience. Most of the companies I work with, they want to use managed clusters only. We've spent too much time on, with COPS, with Spray, with a number of tools for provisioning, custom or vanilla Kubernetes clusters, but it's just a waste of time in the long term to maintain your own deployment. So most of the customers I know, most of the companies I know, they are exclusively interested in the managed clusters and nothing else.
Interesting. And so the use case ends up being having a uniform way of deploying these managed clusters across platform.
Yes, because today we are losing, when we use Terraform modules, it's not that easy to map Amazon on Microsoft cloud, right? Because these clouds are totally different. So if you dive deeply into Terraform templates, it's just a nightmare. So we would like to have a kind of standardized way of deploying clusters. But also what is more important to me is the lifecycle part, right? Because in Terraform is kind of naive. I mean, it just knows that the cluster is up or down, and this is actually all what Terraform is aware of. In case of cluster API, I can imagine that we can, manage upgrades, rollbacks, many more cluster states than with Terraform. So that's also something I'm looking for, because if you have like 200 clusters, we want to know the current state of all of them, and with Terraform, it's not that easy to be achieved.
So
I want to dig a little bit into what you mean by managed clusters in this case, because we've talked about the cluster API management cluster. But when you're talking about managed clusters, do you mean using the managed service on each of the cloud providers? So GKE on Google, EKS on Amazon, and AKS on Azure? Or do you mean to use like CAPZ to provision a cluster on Azure that is then managed by you and the management cluster? You know, the difference is, say in the AKS scheme, you would not have access to the control plane nodes or be responsible for managing the control plane and etcd on AKS. But in the CAPZ scenario, you have access to all of those resources, and you would use CAPZ to manage the control plane as well as the the workload worker nodes.
Yeah, so I think the main idea is to avoid managing the control plane, right? So we don't want to be responsible for etcd and anything related to that. I remember quite a lot of painful migrations from etcd to 0 to 3.0, which is just quite a lot of effort that doesn't bring any business value to the customers. To the business. So we want to avoid managing any kind of control plane. So by managed clusters, I mean EKS, AKS, and GKE.
Thanks for clarifying.
So to answer your questions from the beginning, in terms of contributions, yes, we are very open to any contributions that you'd like to make to the project. We do everything in the open. We have this office hour every 2 weeks. And then everyone's very active on Slack, as you saw. So if you want to contribute, that's not a problem. If there are any like bigger scope changes, we usually do like a proposal process. So we have like a template, and you submit a proposal in the Google Doc form, and then people review and we discuss. But yes, so the short answer is yes. If you'd like to contribute, that's not a problem at all. In terms of maturity, I think the unmanaged story for cluster API is more mature than the managed cluster story. Nader and others can probably tell you more about that, but they're definitely like production users already. It is an alpha project, which means we are not completely protected from having breaking changes to the API in the big API versions. But so far they've been, I think the conversion has been handled in a way that you can always upgrade from older API versions. And we're already at V1 Alpha 4, which means we're getting closer to beta. I think we're targeting beta end of next year, possibly. So it is like quite stable in that sense. The managed cluster story though is still in experimental, in the experimental part of the project. So I don't know if you took a look at the code base already, but the AKS managed cluster types are all in the experimental folder. We were planning to take them out of experimental as part of V1 Alpha 4, but that's where it is today. And then in terms of priority, I know that some people are very interested in the managed cluster story and have been active both in Azure and AWS and others, I'm sure. But I don't think that was where the priority of the main priority of the project was first set. I think the main goal was to get the unmanaged cluster story right. But yeah, that's just my experience. And then what I'm curious about is why, how you think Cluster API would help you with the lifecycle management, because I understand the whole thing that you said about Terraform, but the managed clusters have their own like lifecycle, right? So like if you do an upgrade, like AKS would take care of the upgrade for you. We don't orchestrate any of that. Like, are you on the same page about that?
Yes. Of course, I am aware that it's partially managed by the cloud provider, right? So it doesn't need to be managed by the tool itself. But even then, I'm pretty sure that cluster API should be aware that the upgrade was successful or wasn't successful, or that it was started, so we can get some timestamp where the upgrade was started. We can get maybe some more information about the more details about the actual upgrade, about how much time it took to upgrade every particular node, how much time the entire operation took. So we can collect maybe some metrics. Maybe we can export the metrics into Prometheus and make some Grafana dashboards to see, a wider view on our 200 clusters. Because if the scope is higher, we want to know how much time we need to upgrade all the 200 clusters, and we don't want to do the upgrade, at the same time for all of them, right? We want to do it step by step. We want to build a little bit smarter procedures, like try first with maybe 5% of our customers, maybe with the biggest ones, maybe with the smallest ones for start. So we'll need to build a kind of logic around cluster API. Kind of workflow tool, but cluster API would be the backend responsible for managing everything related to the clusters. Another big topic for us would be, of course, to use Azure Service Operator framework to provision all the other cloud resources like buckets, I don't know, databases, whatever we need. We call it middleware in most of the projects. So the middleware layer is also supposed to be provisioned, not with Terraform, but with operators. So I'm looking into more like into the entire life cycle and so-called day two operations in the future. There may be also cases like cluster migrations. So I can imagine much more cases like this, scaling up, scaling down. So yeah, but I'm aware that part of this of the work that was in the past was done by the DevOps guys is already done by the cloud providers, cloud vendors. So we don't need to put too much attention into the upgrades. But even then, when it comes to networking, like Calico stack or some other network options. OPA, Open Policy Agent. There's a number of components in the middleware that is quite sensitive to Kubernetes upgrades, not mentioning ingress controllers. So yeah, I would like to have a tool that is capable to react for unexpected changes, not only for upgrades, but to be aware of something more than just the cluster. It might be a little bit, too visionary as like for today, but if we want to have everything fully automated, we need to know the state of all the clusters. The clusters need to be aware of middleware. Middleware needs to be aware of the clusters state, and so on.
So I'm just curious, have you considered Azure Arc? Have you looked into that at all?
Yes, but I can't remember too much details about this, but our use case is Kubernetes for sure.
Right, so Azure Arc is I just sent you the page for Kubernetes, like Azure Arc enabled Kubernetes. It's in preview, but basically it allows you to manage your Kubernetes clusters on any platform. And so they already support like EKS, GKE, AKS, cluster API, AKS engine, all the things. And so it makes it really easy to install things like metrics and monitor your clusters on different platforms. And so what you're describing to me sounds really close to that.
Besides just that one, is there a reason, like there are other solutions out there too, right? That do relatively similar tasks to that. Is there a reason why you would choose Cluster API versus a solution from a Microsoft, a Google, a VMware, or some other representative company?
What kind of solutions do you have in mind?
Managed service, similar to
like Antos, for example, right?
Perhaps, yeah.
Actually, this is a very good question. I think this approach should be also considered, but I don't have too much experience in that area. One of the problems we will be facing is that we need to support multiple different clouds in a kind of cloud native way with infrastructure as code in place. And I'm not really sure if if Arc we can achieve this kind of goal today. But I would have a look deeper. I think this is a very good point because we focused mainly on Terraform and Cluster API, and we didn't consider using any kind of tools like Arc or Antus or similar. So that's definitely something we should also look into.
Yeah, not saying that Cluster API can't do what you're describing, but I think it's worth considering also the managed services because they would be more managed, so it's less do it yourself. I mean, there are pros and cons to both approaches. Depends if you want to be more be able to control things more, or if you want like a more managed service experience. But yeah, I think they're both valid ways to go with this.
Yeah, I think why we're asking is more for understanding the differentiation and your point of view of what benefits Cluster API brings that are beyond that. Like we work on Cluster API every day, and we believe in it. We love it, and it's really great to hear a point of view from somebody outside of the project looking to adopt and the reasons why they're passionate about it. And we really appreciate you explaining this to us. Thank you so much.
So yeah, for me, operators actually not only Cluster API but Kubernetes operator pattern is the way to go. And I think this is the future of most of the future applications out there. This is also how it is advertised by quite a lot of Kubernetes creators like Tim Hawking and so on. So I think that this pattern should be a kind of baseline today for building any kind of application. And so that's the first thing. And when we speak about the operator pattern, we can assume, actually, we should assume that any kind of operator, including Cluster API, provides all the basic features out of the box, like scalability, scaling, self-healing. So there is a lot of features. There should be a lot of features built in into the operator itself that we shouldn't care too much about. And in case of Terraform, it is not the case, right? I mean, Terraform is great for a number of use cases, but yeah, it's not. It doesn't provide any kind of high availability today. If we kill the machine where the Terraform process is running, we will have to restart the process again. And if the plan and plan execution takes longer than 1, 2, 3, 10, 20 minutes, it is really a very painful process. So if you consider like managing hundreds of clusters, maybe even thousands of clusters with Terraform, it's just a nightmare. But not only for Kubernetes clusters, but also for other objects like S3 buckets. It is quite a common use case where people are managing hundreds or thousands of S3 buckets with Terraform, and deleting a bucket or creating a new one takes minutes or maybe even hours sometimes with Terraform. And yeah, and there are also some other issues like API API limits that are introduced by all the cloud providers out there, right? So in AWS, I guess, in Azure, I guess it's 1,200 requests per minute. So if you run a bunch of different Terraform processes at the same time, they are not aware of each other. and it is very easy to hit the limit. So your entire CI/CD infrastructure, stops, and so Terraform doesn't scale in the today's form. So these are actually two main reasons for me. Terraform is not that good in addressing more complex use cases and big scale deployments. But the basic one is the operator pattern. I think that all the applications should be already built according to Kubernetes operator principles, with all the good things that are coming for free with the operator. Not mentioning backups or and other things like that. So scaling, so being honest, I would be much more excited to work with Cluster API than Terraform, and I believe you already have this feeling. So I will do my best to evangelize all the companies I work with to try Cluster API. But we are on a kind of POC level today. And I think there should be a little bit more companies interested to develop the platform. I'm not sure if if it is easy to add new developers. How much time it takes for new developers to be productive in the project?
Well, hopefully not too long. And if there are problems getting started, please let us know. We really want to make it better and more approachable for all developers.
Because from the business perspective, it looks today more like we need to hire 2 DevOps guys doing Terraform templates, or maybe 2 Golang developers working with Cluster API, extending the Cluster API, right? So that's more or less how it looks from the business perspective.
Makes sense. Does anybody have any other questions?
Yeah, I wanted to jump in and ask a quick question to Piotr. So I work on ASO, and I just wanted to double check. You want cross-platform for your managed cluster deployment. Is it the case that once you've done that, then you've deployed to your AKS cluster or your GKE or whatever, and then you're okay being more locked into that provider? Basically, the reason I ask is because ASO only manages Azure resources, right? So like you're not getting any cross cloud provider stuff if you've just deployed ASO in a cluster.
Yes, and this is actually a very serious problem because it is not that easy to match to map cloud resources from cloud vendor A to cloud vendor B to be 100% compliant with the operators. So what I was thinking about with my colleagues was the kind of meta operator that would be on top of ASO, Amazon operator, and Google operator, hiding all this. Actually, something similar to Cluster API pattern that would hide all the specific to the cloud complexity behind more generic files like bucket. If you wanted to have a bucket in Google or Amazon or Azure, we should have just a simple YAML file saying bucket name, and that's basically all the complexity behind could be maybe hidden in the lower layer of the operators. I don't know. So yeah, but it's a very serious problem actually. The only solution we found was to build a kind of meta operator.
Have you looked any into to Crossplane? They have, at least my understanding is, they have a that sort of meta operator layer where you can define these abstractions. I forget what they call them, but you can define these abstractions and then you have to do the mapping. They don't do it for you, but you can say like, I would like to deploy a SQL instance, and my definition of a SQL instance has these like 7 properties, and here's how those 7 properties map into into Azure, and those same 7 properties also map into Google's cloud APIs in this way. So I believe that they do support that. I mean, obviously the downside with Crossplane is, at least right now, I don't think any of the cloud providers are giving as much support to that as they are to sort of their own homegrown operators. I know in Microsoft, like we're working quite closely with the cross-plane developers and sort of leveraging some of the code generation stuff we're doing for ASO. And the idea, at least, is we're going to use that same tooling to help level up cross-plane support of resources as well. But it's worth mentioning because they do have that meta operator you're talking about, or at least they're close to it.
We're running really short on time. Nader, you've had your hand raised. I'm sorry, we haven't gotten to it. Please, what were you interested in sharing?
Yeah, I was just going to say there's a really good presentation from Deutsche Telekom in April. So if you're going to go and build your own stuff, then they've done quite a bit of work on like building a layer around Cluster API. Take a look, throw the link here. So it should be linked to the Zoom recording there. And just, it's fine, we can talk offline, but there are differences between, if your main use case for using unmanaged cloud is if you want consistency in terms of, particularly around authentication generally, but we'll leave it there.
This has been a really awesome conversation. Thank you everybody for joining in. We are right at the end of our time, and I just want to say thank you to the community. Anything else we need to hit? Any PSAs before the end, Cecile?
Nope.
All right.
Thank you.
So thank you all. We appreciate it, and see you on Slack.
Thank you. Cheers.